Okay, 10.6 deals with geometric probability. The objectives of this section are to calculate geometric probabilities and to use geometric probability to predict results in real-world situations. So remember that in probability, the set of all possible outcomes of an experiment is called the sample space. Any set of outcomes is called an event. If every outcome in the sample space is equally likely, the theoretical probability of an event is P is equal to the number of outcomes, so our probability is equal to the number of outcomes in the event over the number of outcomes in the sample space. So the bottom is going to be all the possible outcomes, so the total number, and the top is going to be what you're looking for. So if it says like what's the probability of all the people in the class being girls, the top would be like the number that you're looking for, so the number of girls, and the bottom would be the total number of people in the class, so the number of what you're looking for, I guess you could call this, of what you want. The geometric probability is used when an experiment has an infinite number of outcomes. In geometric probability, the probability of an event is based on a ratio of geometric measures such as length or area. The outcomes of an experiment may be points on a segment or in a plane figure. So this is just talking about the types of geometric probabilities, what we can use it for. So we could use it for determining the length of an area. We can use it as for points on a segment or on a plane figure. We're going to go over all of these types of examples. So here it just shows us that we can use geometric probability for length on a segment. So our sample space would be the whole thing, which is the whole length AD. And our event would just be what we're looking for. So we're just trying to see what's our probability of being on BC when our whole segment is AD. So our sample space goes on the bottom, and what we're looking for goes on the top. We can use geometric probability when looking for an angle measure. So our sample space would be all the points on the circle, so the whole thing, and our event would be all the points in the shaded region, so just this part. So if we're looking for what's the probability of being on this piece of the circle from the whole thing, our event would just be this piece of the circle. So remember, our event goes on top, so it would be the measure of this angle, and our sample space would be the whole thing, which we know a circle is 360 degrees. The last one, we can use it for area. So our sample space would be the area of the rectangle, which is the whole thing. And our event would be what we're looking for, so just the area of the triangle. So the area of the triangle would go on top, and the sample space, which is the whole thing, would go on the bottom. So if an event has a probability of P occurring, the probability of the event not occurring would be 1 minus P. A point is chosen randomly on segment PS. Find the probability of each event. So we need to find the probability that the point is on RS. So we need two things. We need our sample space, which is the whole thing, and then we need our event, so what we're looking for. So our sample space is the whole segment, so let's add up all of it together. So we have 7 plus 13 plus 5, which is 25. Our event is just RS, so we're just looking for what are the odds that it is going to be on RS. So RS is 5. So we take what we're looking for, which is 5, and divide it by the whole thing, which is 25. So our probability that our point is going to be on RS is 5 over 25, which simplifies to 1 over 5. So we have a 1 out of 5 chance that our point is going to be on segment RS. Now, probability can be written in different ways. We can write it as a proportion, which would just be 1 out of 5. We could also write it as a decimal, which if we put 1 divided by 5 in our calculator, we would get 0.2. And we can change this decimal into a percent. So we changed something to a percent by multiplying it by 100. So this would give us 20%. So we have a 20% chance that our point is on RS. So there's 2 different ways of writing probability. So using the length to find the geometric probability, we're looking for when our point is not on QR. So we're looking for when it's not on QR. So we're going to try to find when our event is on QR, and then we're just going to subtract 1 minus whatever we find. So our whole sample space, we just add all 3 together, so our whole space is 25. So our sample space is 25. Our event that we're looking for is QR, so 13. So we're going to do 13, what we're looking for, divided by the whole thing, which is 25. So this is the event that it is on QR. Now to find when it's not on QR, we would just do 1 minus what we found. So when subtracting a whole number and a fraction, we need to change this to have the same denominator. So 1 we would change to 25 over 25 minus 13 over 25, which would give us 12 over 25. So our probability that it's not on QR is going to be 12 over 25. We could also do this problem a different way. We could say that when it's not on QR, then it would have to be either on PQ or RS. So then we could just add these 2 together, and that would be when it's not on QR. So then our event would be 12, and then we would just have 12 divided by 25. So 2 different ways of doing this, but we get the same thing. Next, we need to find the probability that the point is on PQ or on QR. So we're either looking for when it's on PQ or QR. So our whole sample space, so the whole thing, is 25. And what we're looking for, so our event, is either going to be on PQ or QR, so we just add these 2 together. So our event is going to be 7 plus 13, which is 20. So now we divide our event by the whole thing, and we simplify this. So 20 divided by 25 would be 4 over 5. And so our probability is 4 out of 5 that our point is on PQ or QR. If we wanted to write this as a decimal, we would just do 4 divided by 5 in our calculator, which would give us 0.8, and then we could just multiply it by 100, which would give us 80%. So we have an 80% chance of our point being on PQ or QR. Next example, a pedestrian signal at a crosswalk has the following cycle. Walk for 45 seconds and don't walk for 70 seconds. What's the probability of the signal? What's the probability the signal will show walk when you arrive? So we need our whole sample space, so the whole thing. So our whole cycle is going to be the 45 seconds when it's on walk plus the 70 seconds when it's don't walk. So we just add 45 plus 70. So our whole space is going to be 115 seconds. Our event, so what we're looking for, is when it says walk. So our event is going to be 45. So to find the probability that the signal will show walk, we just do 45 divided by 15. We can simplify this by dividing 5 on both sides, on the top and the bottom, so we get 9 divided by 23. So our probability that the signal will show walk when we arrive is 9 out of 23. We can change this into a decimal just by dividing 9 by 23 in our calculator. So this would give us about 0.39%, 3.39 as our decimal. We multiply it by 100 to get our percent, so we would have 39%. So we have a 39% chance that our signal will show walk when we arrive. Next example, use the information below. What is the probability that the light will not be on red when you arrive? So there's 2 different ways we can do this. We can find when it will be on red and just do 1 minus that number, or we can just add up when it's not red. So when it's not red means it's either going to be green or yellow. So we need our whole space, which is 25 plus 5 plus 30. So our whole space is 60. And our event is when it's not red, so we just add green and yellow together, so 25 plus 5, which would give us 30. So we do our event divided by our whole thing, and this would simplify to 1/2. So our probability that the light will not be on red when we arrive is 1/2. We can change this into a decimal by dividing 1 by 2 in our calculator, which would give us 0.5. If we multiply it by 100, it gives us 50. So there's a 50% chance that the light will not be on red when we arrive. Use the spinner to find the probability of each event. So we need to find the probability that the pointer is landing on yellow. So we need our whole thing, our whole space, and we need to find our event that we're looking for. So the whole thing would be the whole circle, and we know a circle adds up to 360 degrees. Our event is when the pointer is landing on yellow, so it would just be this yellow part, which is 140. So we divide our event by the whole thing, so we do 140 divided by 360, and we can simplify this to 7 over 18. So we have a 7 out of 18 chance that our pointer is landing on yellow. We can change this to a decimal just by dividing 7 by 18, which gives us about 0.388. And then we can multiply this times 100, which would give us our percentage, which would be 38.88. It's 8 repeating, but we can just put it as 38.8%. So we have a 38.8% chance that our pointer is landing on yellow. Next example, use the spinner to find the probability of each event. So the pointer landing on blue or red. So we need our whole thing, which again is going to be 360. And now we need the probability of it being on blue or red. So we just add blue and red together. So our event is going to be 60 plus 52, which is 112. So we do our event, 112 divided by the whole thing, which is 360. We can simplify this by dividing 8 into the top and the bottom. I believe we get 14 over 45. So we have a 14 out of 45 chance that our pointer is going to land on blue or red. We can change this to a decimal by just dividing. So we divide 14 by 45 and we get 0.31. And we multiply this times 100 to get our percent. So it would be a 31% chance that our pointer is landing on blue or red. Our next example, we're going to find the probability that a point chosen randomly inside the rectangle is in the triangle. So we need our whole space and we need our event. So the whole space is going to be the area of the rectangle. So to find the area of a rectangle, we do base times height, which will be 12 times 4. So our whole thing is going to be 48. Our event is just the area of the triangle. So we need our height of the triangle, which is 4. I got that from this height. And our base is 6. So we do 1/2 base times height, 1/2 6 times 4, which gives us an area of 12. So our event is 12 and our whole thing is 48. This simplifies to 1 out of 4. So we have a 1 out of 4 chance that our point chosen is inside the triangle. We can change this to a decimal, which will be 0.25, and we can multiply this times 100 to get our percent, which would be 25%. So we have a 25% chance that our point chosen will be inside the triangle. Alright, so this is 10.6, just deals with probability. If you guys have any questions, feel free to email me. There is a homework assignment posted too, which is due on Friday. So let me know if you guys have any questions. Have a good one.